All right, so let's review what we have on the calendar for the next few days. So today we're going to have a Beyond Tech sometime, probably 11:15, 11:30. It's going to be on Personal Finance Part 1, and next week will be on Personal Finance Part 2. I've found that very few people have an idea of what to do with their money, so we want it to be as comprehensive as possible. We're going to talk about money and how to handle it. Tomorrow we're going to start our AWS, and I'll talk more about that after our retro. Monday through Wednesday next week, Josh and I both will not be teaching. We're going to have Bobby Norton coming in. Bobby is a super senior developer, used to work at NASA, and he is going to teach us about data science, using probably some of the things we're going to use for the next 2 days. So I wanted to get like a little bit of a primer ahead of time so that when Monday through Wednesday come up, we're not completely lost. Headshots by Han next Friday, so if you want to get a haircut, make sure you get it today so that it has a little bit of time to grow out. Other than that, it'll be at 2:30 next week. All right, so for the past 3 days or so, we've been just doing SQL stuff, and we've used Postgres. And when it comes to whatever language we're teaching today or whatever language we're teaching in the future, there are fads. So back in the day, a long time ago in the 90s, like everything was Java. Like Java was everything. And Java is still around because Oracle backs Java, and Oracle is an enormous company, so Java will never go away. Other languages have come and gone. So you got like Python is really big now in like the data science community, and Google's backing it up. Google's also backing Go, so that's why it's around for a long time. Ruby was backed up by Groupon for a long period of time, but Groupon is pretty much dead. So Ruby is kind of going out. But underneath the hood, like it doesn't matter whatever language that you decide to use. At the end of the day, it's all about getting data from your users and saving it inside of a database. So SQL, no matter what, is absolutely forever. But as you have seen, typing SQL on its own is kind of difficult. I suppose like it's a little bit difficult. You're not really sure how am I gonna, do I have to like run these commands, like do I have to write a file and then like keep track of everything? Like how do I like using Python. How can I use Python and SQL together? There's actually a great library called Psycop. Which basically combines Postgres, SQL, and Python together. And you may have seen this from today's notes. Everything that I'm saying you don't really need to worry too much about because it is all in the write-up for today. So the first thing we want to do is we want to create what's called a virtual environment. Now we haven't taught this before, and I didn't think I was going to today, but I'll talk about what that is. So I'm here on my desktop. I'm going to make a directory called Psycop example. I'm going to cd into Psycop example, open the whole thing in VS Code. We're going to create something called a virtual environment. Have people heard of this before? All right. If you had to explain to somebody what a virtual environment is, imagine we've never heard of it before. What would you say it is?
Obviously, from my experience, I was going to make a project that must exist inside a virtual environment.
Yeah.
Use my term exclusively for that. That, I guess, I mean, I really don't know the ins and outs, but it's like to composite all your libraries and your files together to create your application. But I don't know why that is.
Okay. Who else has heard of a virtual environment?
Is it like a program that runs a program?
It's kind of like a program that runs a program. So a virtual environment is essentially like, imagine if you took it's basically like forking over your computer, like from GitHub. So a virtual environment is, so on your computer, you're going to install many different versions of software. Let's say you're working for a large company and they have software that's very, very old. They wrote that software a long time ago when it was cutting edge and brand new, but software continuously evolves. So there are certain versions of things that no longer work with older versions of things. Imagine for a second that you have like a 1965 Shelby Mustang, right? You've got like the old school like engine, you've got the old school body and everything. Some of the new parts that we make today won't fit in the old in the old Mustangs. That's why people have to source parts and they have to install it. But we want to be able to work on those, like be able to work on everything. So what a virtual environment does is that it basically creates a wrapper around your computer, and you can install whatever kind of versions of software that you want. And at the end of the day, you can just deactivate it and throw it away. So it's kind of like saying, I want to, imagine like a time machine almost. It's like, I want to, whenever I work on this car, this Shelby Mustang, I want to take a time machine back to 1965. I can install any version of engine that I want. I can put any sorts of seats inside of there. Same thing here. I'm going to create a virtual environment by doing Python -m. I'm making a virtual environment, so VENV, which is virtual env. I'm going to name it anything that I want. Most of the time I call it virtual environment. So a folder called virtual environment is created, and then all I have to do to activate it is type source vem bin activate. So I ran two commands. The first one was to create a virtual environment, Python -m. I'm creating a virtual environment, so I'm saying Python, make a virtual environment called virtual environment. At that point, I'm going to activate it. So I'm going to say source vem, there's a folder called bin, and there's a script called activate. So I'm basically saying, run this particular thing that's built in for me. I don't know what any of this says. I don't really care because it just works. And what you'll notice is when I press enter a bunch of times, to the left of my command line prompt right over here, I've got parentheses VENV, which means that I'm currently operating inside my virtual environment. So you can safely assume I can install whatever software I want. It won't affect the rest of my computer. This is just like I have bubble wrap around me. I can do whatever I want inside the bubble wrap, and nothing on the outside world will affect me, and I won't affect anything on the outside world because I'm filled with bubble wrap. So I can install any versions of software that I want, and it won't blow up other things on my machine. So if I wanted to use an old version of Python, and I wanted to change over to that old version of Python, I can do that inside the virtual environment, and it won't affect my machine as a whole.
How do you do that?
There's a script called deactivate that's built in, and then it goes away. If I want to activate it again, I just go with source vem bin activate. So at this point, I want to install a piece of software. I want to install it so that it's not affecting my entire computer. That's why I created this virtual environment. I want to install a library given to me by pip. Pip stands for Python installer program. I don't know. Pip. It's the package installer. So I'm just going to run pip install Psycop G2, and it's going to install Psycop G2, which is that library that connects Postgres and Python together. It's going to install it inside the confines of this virtual environment, so just within this folder here, and it won't affect my entire machine as a whole. There's a warning here. You can ignore it if you want to, or you can just copy and paste and tell them and do what they tell you to do. All right, so today what we're going to do is we're going to create a database that holds the records of everyone in our class with their favorite food. So we're going to create a database, maybe a table, and insert some stuff inside of there, but we're not going to use pure SQL. We're going to use Python and SQL put together. First things first, I want to create my database. So I'm going to create DB called class. I'll call this India class roster. If I jump inside of pSQL and I go to India class roster, you can see I'm inside of this database, but if I look for all of the tables inside of there, there's no tables right now, and that makes sense. I'm going to create a new file called classroster.py, so we're back to Python, and I'm going to do a couple things. I'm going to import the Psycop that I just installed, and I'm going to import the operating system library. I'm going to connect to my database by having a variable saying connection equals Psycop G2. So that's, I'm importing that library. And I'm saying connect to a formatted string. The database name is India class roster. And the user that's logging in is my current user. So this stuff I didn't write myself. This comes directly from the documentation, so I just copied and pasted. So once I have a connection, it's saved inside of this connection local variable. And I want to open a cursor to run SQL queries. From there, I'm going to create my own SQL query, which is create table called students. There's an ID that's a serial that's going to go up and down and automatically increment and decrement for me. My name is going to be a varchar, and my favorite food is also going to be a varchar. I'll execute it, commit it, and then close the connection. Essentially, what lines 4 through 10 are doing is me going inside of pSQL, inside of India class roster, copying this, and running it. The good part about this one, though, is that you can read it as Python code. And it's, I don't know, I personally find it a little bit easier to work with Python and write the SQL queries as strings rather than writing it as its own SQL file. So again, I create a connection to the database using Psycop G2. There's this concept of a cursor, which is, it just comes from the documentation. You have to open a cursor in order to execute any code. I have just a random, this is just a string. This is just equal to create table students with these particular fields and those particular data types. I'm going to execute that query from the cursor, commit it, which means actually save that to the database, and then close the connection. Any questions on this file? Yeah?
VS4, I guess, is the question. I used to work with this very stuff with Android Studio. I used to hate that it was a string because it would not tell you if it's wrong or not in your query.
Yep.
And it used to drive me nuts. Is there any extension or way that VS4 handles that? If you miss one comma or anything in that string, it blows up or it doesn't?
I don't think it does, unfortunately. Okay.
Yeah, so when you with the bar chart for the name and favorite food,
yep.
Is that just default to 255?
It by default goes to the maximum, yeah.
Okay. But if you were to put in parentheses and change it, it would.
Yeah,
okay.
that would limit it.
Each chart is how many bytes?
Each character is, I don't know.
So I was just thinking, it's 255 characters, which I don't know how many bytes there is in a text to go up to 16
Kilobytes, yeah.
Obviously, that's not.
Yeah, I'm not sure. All right, so again, we've got that connection. We open a cursor. We created our query right over here. We execute it, commit it to the database, and then close the connection. So in order to run this, all I have to do is do Python. Actually, before I actually run this file here, let's verify. pSQL India class roster. No tables in the database. We all see that. Right now, I'm going to run Python class roster.py, just like I was running all of my old algorithms. I'm just going to run Python and then the name of the file. Nothing blew up. It just, silently goes forward. And if I go back into the class roster and go /D now, you'll see that I have students and a student's ID sequence that they give to me for free from Psycop. All right. So let's say that I want to run this again, and I want to insert a few people inside of here. So sorry, go ahead.
Can you see the students table too, just so I can see the columns?
Sure. Good question. Students. Oh my God. Let me do \x for extended display. \D students. This doesn't look great. So you have the ID, which is an integer. You have name, which is a varchar, and favorite food was a varchar.
So the other ID that was created, you didn't have to create it.
The ID is right over here. Oh, this sequence thing,
Yes.
the student's ID sequence. Yeah, this is something that Psycop and Python give to you because that's just how Python interacts with the database.
So that's like so you can do your connections, or I'm not sure. I just don't understand.
I would say you only need to worry about this, the one that you create. Everything else underneath the hood is just what they need in order to run it.
Yeah, also to do the thing with the workshop templates with the auto-generate by ID or identity thing, it'll actually do the same thing. It'll give you a sequence table. I think it's just of the IDs. I could be wrong.
Yeah.
I think they use that for relational mapping. I don't know, but that's the same thing you'll get if you do the generate by identity.
Sure. All right, so now I want to create a bunch of SQL queries for insert. So I can just go back over here, comment this one out, and maybe I'll just run. I'll just create a bunch of people. Perhaps I'll do. I'm just going to do. Let's just do 5 people. Kyle. Right. So the way that I'm going to do this one is I'm just going to create another string. So it's just insert into students, name, favorite food, values, favorite food.
Pizza.
And then I'll just kind of copy the same thing again for the other 2 folks.
What's two modulus S?
Modulus S, unfortunately, is the they're not allowing you to do formatted strings when you do C. So you have to go back to the old school way of doing it. Chad?
Egg sandwich.
Eggs sandwich. Egg sandwich. Okay, Hank?
Sushi.
Fancy.
Didn't know that was- didn't know that was fancy. I apologize if I meant it.
So just reviewing what I've got, I'm connecting to the database, specifically the India class roster, as this particular user person. This user person is, for us, is Code Platoon instructors, which is this machine right here. I create a cursor. I'm commenting this one out because I don't really want to execute the student table creation, but I do want to, since I've already done it, I want to execute 3 insert statements. I want to execute insert into students, specifically name, favorite food. The values are going to be 2 strings that I'm going to pass in, and those strings are going to be Kyle and pizza, Chad, egg sandwich, Hank, and sushi. So I'm going to execute these particular statements, commit it to the database, and then close the connection. So if I did select star from students right now, you'll notice that I don't have anybody inside of there. I'm going to quit, run it again, nothing blows up, it looks like, and enter the database. If I do select star from students now, you'll see that I have 3 people in the database where I didn't have it before. Essentially, all I'm doing today is I'm taking all of the SQL queries and executing it with Python. That's pretty much all that I'm doing. Yep.
Does Psycop tell you to close up? Like if it doesn't work, because I know some libraries are like, you tried it, it didn't work.
We can find out. All right, let's see if this runs. So if I intentionally write something incorrect, will it blow up? Yep. Yeah. So it'll tell you if it's broken.
Oh,
Is this what like is this Psycop whatever? Is this running on like Python 2?
No, it's running on Python 3.
Oh.
So this very basic example is inside of your curriculum. So everything that I did type is inside the curriculum if you're someone who wants to go back and to read this. I'm going to do one more example with real estate prices. All right, so whether you like it or not, CSV is going to be around forever. Most people did fairly well when it came to assessment number 2 and doing the stuff with the CSV. And CSV is going to be around no matter what for the rest of the time, because your business people love Excel, and Excel will never be out of business. And they have that file export to CSV, and then that's all they need. So CSV will be around forever. So let's say that we want to grab some data from like the city of Sacramento. This is all part of the curriculum here. So I found this online. It's just like a free data set that was available. All right, so I've got I've got basically the address of a particular real estate place, the zip code, how many beds, how many baths, what's the average square foot, is it a residential or is it a condo, when did it sell for, how much did it sell for, and the Latin loan. So basically what I want to do is, let's say that your business person said, I want to do some sort of like data science or like querying the database. I want to enter, let's have a better one. Your realtor was writing a bunch of stuff inside of Excel and exported it like this, and they want to enter it into the database. So they could fill out a form and type it in one by one, and that would be entered into a database. Or they can just pass you off this entire thing and say, hey, tech guy or tech gal, do this for me. So what we're going to do is we're going to read the CSV, clean up all the data, because some of this is coming in as a number where other ones are going to be coming as a string. We want to clean up all this data and we want to put it inside the database and query to get some sort of insight on many things. So I'm going to go back over here. We're still inside of class example, class roster. Okay. I want to create a new database. We'll call it CreateDB Sacramento Real Estate. It already exists because I did this when I was writing the curriculum, so I'm going to drop the DB.
I had no idea how to do that.
So CreateDB creates the database, drop DB drops the database. So I'm going to drop the database, recreate it, and now if I go into pSQL Sacramento Real Estate, and I do \D, there's nothing inside of there. It's a completely empty database at the current moment. I'm going to create a file called csvexample.py. I'm going to read the file, and I'm going to clean it up. So I've got this code for us already. I'm importing the CSV library. Remember what last week when we wanted to read and write, we did import CSV. I'm bringing in Psycop G2, just like I did with class roster. And I need to have, and I have from IPython import embed. That's that embed library to basically stop it. And I've just copied and pasted. I'm just opening the real estate transactions CSV file, reading it in over here, and just stopping at this point just to see what my row looks like. Now, it's not lecture materials / Sacramento real estate transactions, so I need to download it from the web first. Let's download it. So I'm going to, oh my God, I don't know how to do this. Let us, oh, I know. Okay, so I'm going to copy curriculum, week 4, lecture materials, Sacramento real estate transactions to Psycop example, and it's right there. So I copied it from the curriculum and moved it inside my folder right over here. So I've got all of that street, city, zip, state, beds, and all of the material right here. So again, all I'm doing is I'm opening the file, reading the file, and just stopping at the first row. I just want to see what it is. So I'm going to run Python, CSV, I'm in the wrong folder, cd into Psycop example, and run Python CSV example.py. And it says no module called IPython.
You haven't imported it.
I imported it, but I haven't installed it.
Import OS? Import OS?
I do need that, but later. But right now it says no module called IPython. And on line 3, it blows up because I said, I want to bring in the embed library from IPython, but I haven't pip installed it. So I pip install IPython. I didn't install in the virtual environment. That's exactly it.
So if it's not your computer, you have to reinstall.
You have to reinstall a bunch of stuff, yeah. So I think it keeps track of your version of Python, but nothing else.
Okay.
So it's like a fresh, brand new machine. So if I run Python CSV example.py, I stop right over here. And let's take a look at what the first row looks like. All right, it looks like we have an ordered dictionary, which is kind of nice. And I have street as 3526 High Street, city is Sacramento. Okay, that looks pretty decent. But, you know, it looks like beds is being saved as like a string. Bats is being saved as a string. Like, we have to clean up the data. And if you ever wanted to do any sort of data science or just honestly software engineering as a whole, you have to look at what is the data that I'm coming in. I probably need to clean it. Yep.
So what happens if you don't want to make a mistake? Let's say the realtor just says, "No, I meant to do it that way," but we assume that you want.
It's the perpetual challenge of dealing with business people in general. The short answer is email them and get it in writing from them that it's exactly the way that you want, and then you'll be fine. Because then you can blame somebody else. In a very real life situation, especially when it comes to longitude and latitude, did I tell this story already? Maybe when I flipped them by accident.
Oh yeah.
Yeah. So I have plausible denial. So I used to work for, the story is I used to work for a company which had many branches of their business, 1,000+ branches. Somebody flipped the Latin long by accident, and like on the business side, and I imported and I said, this doesn't look, I don't want to airdrop from Caitlin. Somebody flipped these by accident. So I wrote the code, 4 people approved it, it got merged into production, and then 5 minutes after it got merged into production and deployed, we started getting phone calls saying, the branch is in like Antarctica, it's in the middle of the Pacific Ocean, you know, it's not exactly where it should be. And then when we went back, the data had shown that somebody had mixed up Latin long when they gave me the CSV file. So it's not my fault because 4 people said yes, and the data that I got was bad. So I could have gotten fired, but it wouldn't have happened because I had so much plausible deniability at that point.
How do you test Latin long though? Like, you have to like visually go see, oh, okay, this is the right position.
Sure. With 1,000 branches, I just kind of trusted that it would be correct. But other than that, you just Google it and make sure it's at the right place. So you can spot check it. You're not going to do it 1,000 times, but you're just going to choose
random sample.
Random sample. Okay, it's pretty much good to go. You make the best decision you can. But coming back to this, there are certain things that we want to save as strings. Street, city, zip. It probably zip because where I'm from in New Jersey, our first area zip code starts with a 0. And if you start with a 0 number in the database, they might cut off the first one. So it's probably good to save it as a string. But bats as a string, probably not great. Beds as a string, not great. Square feet, that you have to transfer it. If you want to find the average square foot that you sold, you have to translate it into an integer. It's like you want to clean it up before you put it inside the database.
I was just thinking of like the bats. Sometimes they're called like a 1.5 bats.
Yeah. So let's think about that. Maybe we'll do like a decimal field or something, right? Yeah, 1.5 bath is totally legitimate because that's the one without a shower, right?
No, it's just a sink. So if you just get a half bath,
Yeah.
if they just get a half, then you're
Okay. Well, either way, let's say that we've got this row over here. Let's see, how do I access like the street? So row street, and I get 3526 High Street. All right. This is where it starts to become important to write Python code. Because if you were to try to do this with all SQL, it would take forever. So I'm just going to import a whole bunch of crap, and we'll take a look at it as a whole class. Now, this is huge, so don't freak out. We're going to go line by line. First things first, I import CSV. Then I import Psycop and the OS. There's that OS that we forgot to do a little bit earlier. I'm going to import embed, decimal, and date time because I want to translate some of these things down here into decimals, like 1.5 bats and stuff, and date time, so that the sale date is not saved as a string, but saved as an actual date. And I've got some methods here. So I've got table creation query. And all it does is that it returns this giant thing, which is create table called properties. It's going to have an ID number, a street address, which is a bar chart, a city, a zip code, a state, number of beds, number of bats, so on and so forth. So I'm just creating a table called properties that matches up with all of the fields that I'm going to find inside my CSV file. All clear there? Now, I have another method called clean data. I'm going to pass in a random CSV row, which is this thing down over here, and I want to clean it up because it's some of it, like we said, this is saved as everything is saved as a string, and I don't want that. So there are some things that are really easy. So I'm going to create a dictionary called cleaned. I'm going to return cleaned as well. So street can probably be just as is because it's just a string. City, zip code, state, number of bats we probably want to have as a number of beds we probably want to have as an integer. We could change this to decimals for the sake of, because it looks like everything here is a whole number, I will just keep it as an integer. Otherwise, I would change it to a decimal. I'm going to turn this into an integer, turn square feet into an integer, and then I'm going to turn the date into what's called stringified time and save it as like an actual date, but saved as month, day, and year. So from what you passed in, which looks like this, I want to save it as a date time object so that I can put it inside of the database, not as a string, which is 09/09/18. That's when I sold it, month, day, and year. I've got the sale price. That should probably be an integer. And the Latin long, because there are decimals at the end of Latin long, if I'm not mistaken. Yep, 38.63, 121 dot. I'm going to turn that whole thing into a decimal. Actually, for the sake of, yeah, why not? We'll turn this bats into a decimal. Yes?
Why decimal not float?
Why decimal not float? So I think
Bit limitation?
it might be that. I think there's a reason why I chose this. I think I tried float and it didn't like it.
Maybe it's better precision.
Maybe float
I
round
wonder
up
that.
or round down, so if you get 0.5. Round it up or round it down.
Now float, it might be a precision thing where it's like this decimal will literally just take it and put it inside, which is what you want rather than float. Float could round up and down, I'm not sure. Yeah, you might be right. But I remember doing float and it didn't like it, so I just put decimal and it worked. So what I've done here is I've created an entire, this is called like a Python script. So if they ever tell you about writing scripts, and you don't want to do OO stuff and you like this type of thing better, it's very linear. So I'm going to import everything that I want. I've got a method that basically returns the table creation query. And since I have it within a method, it's easy to find. I've got clean data. So it's given a CSV row, I'm going to clean the data, return that cleaned data, and I'm going to execute it. So same thing as before. I'm connecting to the database called Sacramento Real Estate with my particular user. I'm going to create my cursor, execute the table creation query, which is here on line 9. So it's going to create that table, read the CSV file, read everything as a dictionary, clean the row, and then insert into the properties all of this gross stuff. So this took me forever to do, so just letting you know. But essentially what it's doing is insert into properties these particular columns. The values are going to be a bunch of strings. And then the values of each one of those, this first command S is going to go with the clean data street address. The second percentage S is going to be the city, then the zip code, so on and so forth. So I'm basically reading through an entire file, cleaning up the data, inserting it into the database, committing it, and then closing it. Now, this is probably easier to do if you just have 20 rows just to do it manually. But imagine you have like a really high producing realtor in an area and they're selling, thousands of properties. I don't know if that's actually possible, but they're selling thousands of properties. Going one by one is going to take forever. Versus if you write a script like this, and it's going to take a fraction of a second because you wrote the program to do it.
Also changing that too.
Yep.
So you have the string literal, I think you said that the percentage side of that.
Yes. Mm-hmm.
Why do you have to put all of them or however many that is? Why can't you just put like a range, like 12 or something like that? If it's that they have 100 fields or something,
Yeah.
you have to put 100 of those?
Yeah. That's just the way that's the limit. That's unfortunately the limitation right now on this, because when you run this execute statement right over here, it does. Oh, this might not work. We'll find out. This execute statement needs to be formatted in like the perfect way, and this is the only way that I figured. Like it took me like an hour to try to get it to look like this. It was annoying.
So using the strings, but you clean the data to integers, decimals, stuff
Yep.
like that.
Mm-hmm.
So it will still go into the database as those integers, decimals.
I believe so. We'll find out. Okay, let's try it.
I was wondering if percent D.
Oh no. Okay, I'm just going to close this out. All right, so let's just double check. We're going to go into pSQL, Sacramento real estate, \D, nothing inside of there right now. \Q to get out, and I'm just going to run Python. Oh my gosh, please work. And it looks like there was just a warning, which is okay, but nothing blew up. There was no error message. All right, so it looked like it executed properly. Let's see if it actually did. So if I go pSQL Sacramento real estate, \D, there's a properties table now. So let's just do select star from properties. Let's just do limit 1 so that I just get one of them rather than all 20. And just like that, I've got that first thing already put inside of there. And if I do select star from properties, I get all 20 of them. So if I do, let me do count.
Those are the correct types.
Yeah.
19. I don't know, let's find out. \D, \D properties, and integer,
I thought you were
numeric.
saying throw me off.
Yeah.
That's
I think %S most of the time stands for string. In this particular case, it's just saying like it's going to be a placeholder for whatever. Because otherwise, since I created the database in such a way where it says I'm only going to allow an integer and I'm going to only allow decimals for other things, it wouldn't have saved into the database if it was the wrong data type. So if it was a string, it wouldn't have saved at all.
It might not matter though.
And like this is where the power of Python and Postgres come together. If you had to do this on your own, just using Postgres, it would take forever. But now that you know like Python, you can clean up the data. It's like, oh, this is coming in as a string, but I need to read it in as an integer instead. So you can change that really easily just by doing int. But if you didn't have access to that, it does take a lot longer. In a very real life scenario, I was working for DRW, and we were doing stuff with Oracle and Python. My boss there was basically like, you have to do everything in Oracle as much as possible. So I said, all right, I'll try it. It took me forever. And by the end, I realized that I couldn't actually move forward. And he's like, oh yeah, let's just do it in Python then. And then I was able to finish in like 25 minutes. So there's a lot of power of having the ability to do stuff with data in Python prior to inserting it into the database. So with the data out of the CSV, and now it's the database, now you can query it and you can get some really great insights. You can answer things like, are single family homes, residential homes, or condos more expensive? What's the most expensive house and condo sold? Like what's the cost per square foot? You can calculate all of that using the Python code. How much does each bedroom cost for a house in Sacramento? What if you wanted to get more than one bedroom? What if you wanted to get fewer than one bedroom? You can do the same thing for bathrooms as well.
So we would create methods that use the cursor and kind of like generalize like our joins and stuff like that, so we can just plug and play anything.
We don't have any joins here because it's only one table.
Yeah. Well, yeah.
Yeah. So let's try to execute this real quick. I'm going to just comment out a whole bunch of stuff because we've already executed the table creation query. So just comment this, Let's throw embed over here. So I'm connecting to the database, creating a cursor, and I'm just going to embed real quick. Run this, Python CSV example.py, and I'm stuck over here. So if I have cursor, it's a cursor object, and I just want to execute, what's an easy one? What's the most expensive house that was sold? I don't know. There's a whole bunch of prices over here. I think it's probably this one. I think this looks like it's in ascending order, which is nice, but we can find out for certain. What is the query to find the max? Query to find most expensive house. I think it's like select, I don't know. Select something from properties. Yeah, I'm looking for the max. Okay, so select max. Maybe
price, whatever the column name is.
Maybe price.
Do you just want the price, or do you want the listing of that house?
Let's. I mean, I don't think it really.
Select everything.
Yeah.
From properties where.
Select star.
Yeah, select star.
From properties.
And yeah, where price is max price. Yeah.
Where max price. Limit 1.
Where properties are price.
I don't know. Let's just see if this works. Actually, let's just do select star from properties to see if that works first. So like cursor execute select star from properties. Okay, let's say a equals cursor execute select star from properties. A gives me nothing.
Maybe max everything. Like everything from property.
Maybe. I don't know. Yep, what's up?
You know when you're in SQL or specifically, well, it doesn't matter if you capitalize or don't capitalize select or whatever. But
Yeah.
it's like or from. But sometimes you have select capitalized and sometimes.
Oh yeah, I mean that's.
So do you have
short answer is you don't need to uppercase anything.
Even in the Python.
Even if you're in Python or in
Right,
SQL.
I know
Yeah. So I try to remember to capitalize the things that are SQL specific, and then I lowercase the things that are that you can substitute in and out. So this is not executing the way that I want it to. So I'm going to Google that. So query Psycop G2 execute query. Basic module usage. Connect, create table. Oh, it looks like, it's execute and then fetch 1. Interesting. Let's see this. All right, so let's say cursor execute select star from properties, cursor dot fetch 1. Is that what it was? All right. So I just got one of them, which is the very first one. There's that 1, 2. Oh, I actually have all of them. Interesting. Okay. So if I say a equals underscore, and I get that whole thing, and if I just get the first one, I got, okay, whatever. How do I get the max price? So I want to get this. I want to get this number essentially is what I'm trying to get to. What we said probably was right. Select star from properties where max price. Where price equals max price. Limit 1. Actually, I don't think you need limit because it's going to go. Okay, let's find out if this one works. Semicolon. Thank you. All right, let's try this again. We're going to have the cursor. And we're going to execute this whole thing. Nope. Price does not exist. Like that? We'll try it. I don't know. It's not happy. Go ahead, Nick.
Inside the max.
Yeah. Let's find out. It's a bunch of trial and error until we figure it out. Cursor, then execute. Current transaction is blank. Yeah, that's blank. Okay, that's fine. Oh, it's because I already have something inside of the cursor. So let me exit here. Run it one more time. Cursor. I have the cursor. Cursor.execute. The properties.price does not exist. So let's exit real quick. Let's see what it is. So pSQL Sacramento real estate.
Oh, it's sale price.
/D properties. Sale price.
That's classic.
Yep.
Yeah, I'm going to need the properties in front of it. If that's on the table. Yeah, because it's looking at from properties.
Yeah.
Yep. So let's try it, run it one more time. So I'm going to run Python CSV example.py. I have access to my cursor. Cursor.execute. Nope. Aggregate functions are not allowed in where, so it's not that one.
On.
What's that?
Sorry, on.
On is for a join.
Google that. Yeah.
The aggregate functions placement is going further here. Yeah, I mean, now the transaction price. That's all we want.
Yep, I think this is actually going to run.
How
Cursor.execute.
do we get the whole list?
Select max price. Current oh my gosh, it's because you can't run it that many times. Cursor.execute. All right, cursor.fetch 1200, 12, this whole thing. So it's select max price. So I think what you're actually looking for, select star from properties, order by max sale price, limit 1. I'm pretty sure this is it. We'll find out.
Yeah.
Cursor.execute.
Does anyone remember how to like order by price descending?
Let's find out. Postgres.
Yes.
Order by max.
I think that'd be a lot easier. It just takes the first one from instead of using aggregates.
Basic SQL.
Yeah.
I'll do it ordered by. It's like it's ordered by it is ordered. Yeah, you can order by sale price.
Because if we just order by the price descending, it'll order by the descending. Just order by the price.
So you're saying you don't need the max. Okay, let's try that first. I think you're right.
Oh, yeah, to do this.
All right, so let's Python CSV example, cursor.execute. Paste this in there, please. Okay, cursor.fetch 1. And we have that one over here. It was sold for $120,000. $120,000. So from here, we're able to basically query things inside of SQL, get Python objects back, and then maybe we throw this in an array. Maybe we find an average. Maybe we iterate over them and get all the sale prices. Maybe we get all the sale prices with the number of bedrooms, so we can figure out the average number of bedrooms. Like there's a lot of data that you can derive out of this.
Fetch 1, does it return an object?
Let's find out. Let's say A equals underscore. It's the type of A. That's just tuple. So you can turn a tuple into an object. You can turn a tuple into, you can get all the things and put it inside of an array. It's up to you. right, so the challenges we've got for today, and then we'll take a 10-minute break. One is I would run through all of this, and today is Thursday, so we're going to pair up again. I would read through all this and just try everything. Everything that I typed, everything I copied and pasted is all written over here. Your job is to basically figure all of these questions out here at the bottom. And you're going to have one challenge for the next 2 days. It's also going to carry over into Monday through Wednesday of next week, which is Chicago salaries. Now, I wrote this one. This is the first time that I'm running it. So essentially what we're going to do is the city of Chicago publishes all of the data inside of for their salaries for all of their workers. So you have every single public employee, what their position is, how long they've been there, what department they're in, you know, whether they're full-time or part-time. You can figure out a lot of things from there. Like who's being paid the most, who's being paid the least, what's the average salary for the department, like which department do you want to work for if you want to make the most money on average? Which department do you want to not work for if you want to with the least average salary? What's this difference between full and part-time workers? What's the difference between men and women? You can figure that one out from the data here. Objectively, you can figure that one out. What's the most common first name, most common last name? So this will walk you through it. Number one, get the data set from the data portal. There is a lot of rows, like 50,000 rows. If you were trying to do that yourself or through Excel, it would take forever. You're going to create a database with first name, last name, job title, full or part-time, department, and annual salary. Clean the data, and then you query the data. This is a large project, and this is what people in their full-time jobs kind of do, to glean things out of it. But we're going to be practicing a lot of stuff here.
What would be the title of a person who would do stuff like this?
It's data analyst, yeah, data analyst. It's roughly the level that you'd be entering it as. Yeah. Cool. Let's take until 11:25, and then we'll come back. We'll do a quick Beyond Tech, and then we'll move on to today's challenges.